Resistance is the proportion between the push that you give to charge and how much it actually flows. It's literally a measure of how much a conductor opposes the flow of those charges. It's how much the material resists a current flowing through it. This usually arises from the electrons, which are the current. As they flow through the conductor, they'll bump into the atoms that the conductor is made of. So what affects this resistance? Well, there's three main things that I want to talk about in this video. Firstly, the length of the conductor can affect it. Let's take a piece of wire as an example. The longer it is, the more chances there are for an electron to bump into atoms as it goes down. A longer piece of wire just has more atoms, so there's more chances for it to bump into that. We can take an analogy of a corridor filled with a crowd of people. So the corridor is the wire, the crowd of people are the atoms, and you are the electron, and you want to run down this corridor as quickly as you can. Every time you bump into a person, that's a little bit of resistance, right? And the longer the corridor is, the more people there are in total, so the more likely you are to bump into people. There's just more opportunities for there to be some resistance. So the longer a piece of wire is, the more resistance it will have. The thickness of a wire can also affect its resistance. Let's use our corridor example again. Let's imagine a very, very, very narrow corridor that you're trying to run through, and the corridor, again, is full of people. If it's very, very, very narrow, you're probably going to bump into every single person standing in that corridor. If it's a little bit wider, you might be able to avoid some of those people. And if it's a lot wider, then you're even more likely to be able to weave between those people. So the thicker a piece of wire is, the lower the resistance is. And the third thing that can affect the resistance of a wire is its temperature. So increasing the temperature of anything will make the particles inside it, the atoms inside it, vibrate more vigorously. The hotter it is, the harder they'll vibrate, the further they'll move, the faster they'll move. So let's imagine our corridor one more time. If this corridor is cool, if the temperature is low, then these people would be standing perfectly still. But if we increase the temperature, these people are going to start jumping around. Which one do you think will be easier to run through? The one where the people are standing perfectly still, or the one where they're leaping all over the place? I think it's the one where they're standing perfectly still. If they're leaping all over the place, they're just a lot more likely to bump into you as you're trying to run down the corridor. And if they bump into you just right, they might even knock you backwards a little bit. Resistance in a wire works exactly the same way. The hotter the wire, the higher the temperature of the wire, the more vigorously the atoms are vibrating, and the more resistance they will have against those electrons trying to flow. I just want to say one thing before I get too many pedantic comments on this video. The corridor analogy is not perfect, but I think it's a really nice way to sort of visualize what's going on inside these wires, and it actually really helps me to remember these important rules. The longer, thinner and hotter wires will have a higher resistance, and shorter, thinner, cooler conductors will have a lower resistance.